So as you look at part B, our function f of x is equal to 2x squared plus x minus 10 over x squared plus x minus 6. This time I did not give you the problem in factored form, so that's where we need to start. Our numerator happens to be a trinomial with a leading coefficient of 2. We've talked about this before. In order to factor a trinomial with a leading coefficient of 2, you can factor by grouping or you can factor by trial and error. I tend to factor by trial and error, so we're going to have an x, and we're going to have a 2x. And then as you look at that negative 10, we're going to have a 5 and a 2, and then we have to think about what's happening in terms of those signs. It looks like if we had a negative 2 and a positive 5, we're going to get everything that we need. So again, in order to double check, you can FOIL this out, and you will see that yes, we do end up with what we need here. So next off then, the denominator, same thing, we need to go ahead and factor that. This is a trinomial with a leading coefficient of 1, a little bit easier to factor, so it looks like we're going to end up having an x minus 2 and an x plus 3. So now that we have this then, the next thing is to write down the domain. And once again, the domain comes from the zeros of the denominators before you cancel any common factors. So the two x values that we can't use here are going to be positive 2 and negative 3. So let's write that down. Set all x values such that x is not equal to 2, x is not equal to negative 3. Now our next step then, before we talk about all the other pieces, and in particular the asymptotes, now we need to think about factors that are common to the numerator and the denominator, and we need to cancel any factors that are common. So as you look at this particular problem, notice that the x minus 2 does show up in both the numerator and the denominator. So our function, f of x, when we cancel those common factors, ends up being 2x plus 5 divided by x plus 3. Now, in order to make the comment that I still don't like that x value of 2, I'm going to put a little comma here, and I'm going to say I still don't like 2. So that then is an equivalent function to what we started with. And what I'm going to do is use that new and improved version of f of x for the rest of the problem. So, okay, y-intercept, that means we're going to put in 0 for x. So we're going to have f of 0 in our new and improved. So that's going to be 2 times 0 plus 5, and divide that by 0 plus 3. That's going to be 5 over 3. Well, 5 over 3 is 1 2/3. So I can come over here and put a dot on the y-axis at 1 2/3. X-intercept then, I can find my x-intercept by finding the 0 of the numerator of, again, my new and improved function f of x. So 2x plus 5, the 0 of that, if you need to, you can go off to the side and set it equal to 0. Subtract 5, divide by 2. We know that the 0 is going to be negative 5 halves. So our x-intercept then is going to be negative 5 halves. Well, okay, we can plot that as well. Negative 5 halves is negative 2 1/2. So we'll put a dot there at negative 2 1/2. Vertical asymptotes come from zeros of the denominator. But once again, we have to do the vertical asymptotes after the cancellation. So I'm going to come to this new and improved f of x, and the only factor that is still hanging out in my denominator is x plus 3. So negative 3 is the 0 associated with that factor, so our vertical asymptote then is going to be x equals negative 3. So let's go ahead and put that on our graph. X equals negative 3 is going to be a dashed vertical line that goes through this x value of negative 3. Horizontal and oblique. Once again, in order to figure out if we have a horizontal or an oblique, it's all about the degrees. Now, this time, because these guys were multiplied out to begin with, it's a little bit easier to read off the degrees. So the degree of the numerator is 2, the degree of the denominator is also 2. So once again, you might want to go back to the handout from section 5.2, and if the degree of the numerator is equal to the degree of the denominator, that means that we're going to have a horizontal asymptote. So I can come down here to oblique and say none. And in order to find the equation for my horizontal asymptote, it's going to be the ratio of the leading coefficients. So we have a 2 here, we have a 1 here. 2 divided by 1 is going to be 2. So one more time though, remember that the author will always request you to write it as an equation. So our horizontal asymptote is going to be y equals 2 over 1, but that's just 2. So it's y equals 2. So once again, that's going to be a dashed horizontal line at y equals 2. So let's put that in. Dashed horizontal line at y equals 2. And our graph is going to approach that dashed horizontal line to the left and to the right. So now our next piece then is to think about the sign chart. I'm going to go ahead and erase, and then we'll do the sign chart.